How's it going, everyone? Welcome, Euler Gonzalez here, and today let's going to continue explore about now the deep dive in JavaScript. This is a course that is from Kyle Simpson. Shout out to Kyle Simpson. He's a software engineer that is also an author of several books of JavaScript. But the point is that we want to understand what are the fundamentals of JavaScript. So anytime that we need to create some sort of features or for any interview process that we need to pass through, we know what JavaScript is doing behind the scenes. So we have now the certainty, unlike now other developers or among the community, where since the barrier entry is so low to be a JavaScript developers, now what happened is that most of the time we are just guessing what is happening. And the point of this is to eliminate that by truly understanding how the things work, what it does, what is the inner mechanism, and particularly the pillars. So, because Kyle Simpson mentioned that this is now the pillars that we need to deal with, right? Such as the type system, the scope system, as well as the objects orientated or object-oriented system. It is important to understand first is the type system. So to make a quick recap of what we went through, that it was to initially understand what is the primitive, what are the possible primitive, such as undefined, null, symbol, string, boolean, big int, all right, and also another primitive which is called an object. It is not a primitive because it is value. You can now aggregate values to this. Therefore, if you have that ability, it's not a primitive. So, because we look at what is the undefined and the null and the use cases with, especially with the null, all right, which is an historical error on JavaScript, that anytime you want to get the point or the value or the type of a null, it give you an object. And there is for historical precedence that if you want to unset a value, a primitive value, you use now undefined. But if you want to unset an object which is a reference in memory, well, you use now an object here, all right? Or you use now null. And because null is used for objects, this is the reason why it's now giving you an error, that kind of type of errors. Again, this is for historical reasons, and if you don't want to break the entire internet, this is what it is. And then explore about is the string. And here we are, right? So what is a string? Okay. So what is a string? And strings in JavaScript are represented by code points, specifically code units. But what is this? So code points, or the way of how now JavaScript characters are encoded, is through the UTF, which is the Unicode transformation format. What does it mean is that this particular Unicode is also branched, or it has several encoding representations, which mean that as you read about this, you're gonna take, it's gonna read about the string values here. Okay. It is surrounded by double quotes or single quotes. Here is indistinguishably, and also by backticks. Okay. This does not necessarily correspond to the number of visible characters. This is also important to understand that the length is not corresponding to the visible characters, and we're gonna see why is that. because this is where it comes the JavaScript characters encoding, something that is way underestimated, or a lot of people just thinks that just by the fact that you know that this is Unicode, and perhaps you have heard about UTF-8 or UTF-16, you think that'll be enough, and that you are not even close to that. Why is that? Because it turns out that Unicode is a variety of other concepts. So it turns out you need to understand how a variety of aspects of Unicode works, and even to consider concepts from USC2, which is 2-byte universal character, which is similar to the UTF-16 but not quite the same. So because Unicode is the umbrella term for different character set, one of them is okay. Yeah. So since Unicode is the umbrella term to describe a variety of encoding or character set, a variety of char set, okay, such as USC2, okay, USC2, the 2-byte universal characters, UCS2, or the 2-byte universal character, okay, universal character, which is similar to the UTF-16 but not quite the same, exactly, which is similar to UTF-16 but not quite the same. It's important that most JavaScript out there use that. So Unicode defines all the characters that we can represent universally in the computer programs. So Unicode represents all the characters that we can define, that we can represent universally, Unicode define all the characters in plural. Okay, Unicode define all the characters that we can represent universally in computer programs. In computer programs, by assigning a specific number to each. Okay, Unicode defines all the characters that we can represent universally in computer programs. Okay, and this number, okay, this number range from zero all the way up to 1111 for 1111 for 1111. In hexadecimal, this. In hexadecimal is this. You got 3, 6. It is important that most JavaScript engines out there So depending of the implementation, it is important that most JavaScript engines out there can either use USC2 or UTF. Okay. Since V8 use UTF, all right. So the standard notation for Unicode is U as follows. Exact. This is not describing the conventions. So the standard notation so here we are describing is this, the UTF, right? Since Unicode is the umbrella term, Unicode is the umbrella term for a variety of char sets, such as USC 2 byte universal character, which is similar to UTF-16, but not quite the same, all right? However, Unicode defines all the characters that we can represent in computer from the range to 0 up to 10 4 times 4F, right? Which is in hexadecimal. Since UTF format, okay, UTF format, the standard notation for Unicode. Exactly, the standard notation from Unicode is that. So the standard notation of Unicode is U, the letter U, plus followed by 4 to 6 hexadecimal hexadecimal, all right, characters. Okay, so the standard notation of Unicode is U followed by 4 to 6 hexadecimal characters. So for example, the heart symbol, which is U plus 2764, which is this. The first group of code points in Unicode, the first group of Unicode in code points is, the first group of Unicode in code point is called BMP. And what's BMP? It's a basic multi-language plan, or BMP. It contains all code points from 0 to 4 times F here, right? Which is the most frequently used characters. Now, this is interesting because if we use something like this, what will be the hexadecimal of that? So it means that that symbol or that character is the length 1. Is of length 1, right? All right. Which is this. So the first group of Unicode points is called BMP, which is the basic multilingual plan. Anything that is go beyond that. Okay. The first group of 65,535 Unicode characters or code points in Unicode, it is called BMP. All right. However, it is fairly straightforward and they can fit onto single to that. They can fit in a 16-bit representation. So this can represent with 60 bits. Okay. Exactly. They can fit into a 16-bit representation, or they can fit into a 60-bit single character in JavaScript, right? So they can fit a 60-bit single character, or exactly, they can fit into a 60-bit single character in JavaScript, or 2 bytes. So anything that is beyond this enter in the realm of astral plane. Enter in the realm of astral plane. Surrogate pairs extended BMP or astral plane. This BMP corresponds to the first group of 65 code points, which can be represented with 16 bits or 2 bytes to be exactly. All the rest of the code points are grouped into the supplement planes or astral planes. Okay. The rest of the group are implemented or are defined. Exactly. The rest of the group are grouped into 16 or into additional 16 into 60 so-called supplement plans. Exactly. So the rest of the groups are grouped into 16 bits. Additional bits or 2 bytes, 21 to be exact, when representing characters above that. So JavaScript store as a pair of 2 adjacent 60-bit known as surrogate pair. So for example, the Unicode of this, all right, or the code point, because this is the code point, the Unicode code point, of this, right? So if I say, for example, which is, let me open now, here is that. If I open up that here and say, hey, I want to transform this string from code point all right, to give me that. So I want to look at this hash table that I have here. I want to look at this hash table that JavaScript has internally, and therefore get me is the item 127,878. Retrieve me that, and there is now a firework. But this is it. So for example, the Unicode, the Unicode code point of this, the X value is this. So JavaScript stores this as two surrogate pair symbols, where alone they don't mean anything. For example, we got now this, which is gonna give you is this, which is a firework. All right. Why is this important? Because it will affect is the length of the string, and we're gonna see that a little later as they mentioned here in the chapter 2. The other is the scale. Let's take a look at that. Let's take a look at that. Primary and primitive with properties, and primitive assignment. Assigned by value copy. Exactly. Primitive assignment. He was looking at now the primitive behavior, primitive immutability. All primitives are immutable. Means nothing in a JavaScript program can reach into the contents of a value and modify in any way. All right. So you get this, and then we dive deep into this, which is part of the coercion that's going on here. Hello plus this, even string value, which look like merely an array of characters. An array contains a typically mutable, is immutable, like this. So for example, if you want to add that, they cannot be added. All right. This is another basic primitive immutability. I really love it. I really love it. Why this is important? Because it will affect the length of strings. And here we're talking about is now primitive immutability. Immutability, right? Primitive immutability, especially with a string. String example, like this. So what is the exactly? So what is the value of this? You have greetings equals hello point, right? And then you say, hey, I want to now add this. I want to add at the greeting position. All right, I want to add to that position is this value. All right, and then I want to take a look now at what is the greeting here. And as you can see, it only prints that hello. Just interview question. You know, interview question. Exactly. What is the length? So what is the length value of this? I think I don't have that. I don't have that. Bullshit. Now what I'm doing is also taking notes to get that as an interview question. Um, what is the length of value of this? 2. Is it astral plane? How Unicode represent exactly how Unicode represent charts. Exactly, astral plane. How Unicode chart set beyond the basic multilingual plane is represented as a pair, as a surrogate pair, as a surrogate pair, right? How Unicode chart set beyond the basic multilingual plane, or the BMP, is represent or are represented as a surrogate pair, are represented as a surrogate pair, or 2 pair of 16 bits, where JavaScript store each character as 16 bits, making this icon belonging to the astral plane. aka value length is equal to. So it comes after the astral plane. If you know what it is, yeah, astral plane, how Unicode characters set beyond the basics. The MVP, this is actually that. Yep, another interview question is that immutable string examples like this. That's a very good question here. The nature of primitive values being immutable is not affected in any way by how the variables or object property holding the value to declare. For example, whether const, let, or var are used to declare the greeting variables, the string it holds is immutable. Const doesn't create immutable values, and it declares variables that cannot be reassigned or redeclared, aka immutable assignments. See the scope and the closure, title of this series, and more information, and so on. Primitive with properties. This is known as objects. All right. So unfortunately, is rendered is equal true. This snippet looks like adding a property is rendered to the value in greeting, but this assignment silently failed even in a strict mode. Property access is not allowed in any way, or nullish primitive values no longer undefined, but properties can be accessed on all the other primitive values. Yet that sounds counterintuitive, because len cannot be set, but it can be accessed to. Alright, so you cannot add properties to this. The language we're gonna silently fail, which is horrible, even in a strict mode. Additionally, most of the primitive value types define in their own method with specific behaviors inherent of that type. So as already briefly mentioned in chapter 1, technically this sort of property method access on primitive values are facilitated by an implicit coercion called autoboxing, which is part of this abstract operations that's happening behind the scenes, or these conceptual operations that happen at the ECMAScript language, right? We don't have access to that, and that happens on a different particular events. Okay. All right, and we're back. All right. So you can reassign that primitive. Okay. And primitive assignment are by value copy. All right. Again, very important things and string behaviors. Okay. So string behavior, string value has a number of a specific behavior that every JavaScript developer should be aware. Very, very interesting, bro. Oh, here we go. Primitive assignment. Any assignment of a primitive value from a variable container to another is value copy. All right. Most of the time we want is to copy is objects. So inside the JavaScript, it may be the case that only 42 values exist in memory, and the engine points both my age and your age variable at a shared value. Since primitive values are immutable, there is no danger in JavaScript doing so. But what's more important to you, us as developer, is in our programs, my age and your age act if they have their own copy of that value rather than sharing it. So because we don't know, and it doesn't mention anything of that. Primitive assignment, primitive immutability. I really love that particular example. Okay. Why it is important exactly? Exactly. Why primitive immutability? And string behaviors here. And string behavior, bro. And string behavior. Exactly. And string behaviors. String behaviors. String values have number of specific behaviors that every JavaScript developer should be aware of. String character access. Though strings are not actually arrays, JavaScript allows to access like an in array style base. Is a value expressions between the array like doesn't resolve to a number, the value will implicitly coerce it to whole integer numeric representation if possible. If the value expressions resolve to a number outside of the range or is not a number, okay, the access will instead be treated as a property access with the string equivalent property name. If the property access does fail, the result is undefined. Note, we'll cover coercion in depth later in this book, but here we're talking about is the string character access. So string character access, string character access, whether it is like in an array style like, all right, and their value will be coerced, right, where their value will be coerced, value coercion happens when trying to access to that position in the array. All right, value coercion happens when trying to access to that position in the array. First, exactly, value coercion happen first to resolve as a number, all right, if it's not as a string. If you pass, value coercion happens first to resolve as a number. If you pass one, or a string, or undefined if it's not founded. If it's not found. Then we look at the character iteration. Character iteration. string character iteration here. So here we can explore similar like using is the iterables or the iterator. Okay, string are not arrays, but they certainly mimic array closely in many ways. One such behavior is that like arrays, strings are iterables. This means that the character code unit of a string can be iterated individually. Exactly. Whether it's like this, and this will be the same. Values such as strings and arrays are iterable via spread operator, for of, and array from. If they expose an iterator producing method at the special symbol property location symbol.iterator. See well-known symbols in chapter 1. Known symbols in chapter 1. JavaScript predefines a set of symbols or private information that can represent certain meta programming hooks. That represents certain programming hooks. That's interesting because well-known symbols represent is special meta programming hooks on objects. Special programming hooks on objects. Interesting. These symbols are stored as a static property on the symbol function object. Okay, but again, some of them represent, these well-known symbols represent certain special metaprogramming hooks on objects. Interesting. Okay. So this is something that can be triggered a behavior on objects. So global symbol registry. Often you want to keep symbols values private. And this is it. Okay, but this is the known well-known symbols are like that. And the way you can have access to, or these symbols are stored in a static programming or symbol here. So if you take a look at the symbol, JavaScript now store this well-known symbols. Store in static properties as a static properties. Interesting. So this is now hooks. It allows you to access, or it represents certain meta programming hooks in objects. Interesting. Async iterator has instance. Hey, if this is instance, certain meta programming hooks in object. That's what it represents. If you can have access to, or if you want to check the instance, it's going to get spreadable. It's iterator. Alright. Symbol.iterator, which allows now to have access to that internal well-known symbols, bro. Interesting. As well as the match. Match all, replace, search, symbol search, string.index of here. Foobar search. For regular expressions and a string. Interesting. Species. The sensing of species allows execution of arbitrary code may create security vulnerability. Okay. Split. which is something that is used in regular expression, and strings, to primitive that allow you to call these abstract operations, or these metaprogramming hooks to a string tag. Looks up this symbol on this value for the property containing a string that represents the type of objects. That's interesting. So that represent is the type of the object, man. The type of the object here. Which is to string. It is from this object dot prototype. So I want to have access to the prototype, that I can have access to the to string tag, but I think to string tag, that's interesting, and return the validator. To string tag. Object of prototype to string lookups the symbol of this value for the property containing a string that represents the type of the object. Object to string dot call object of string dot call. The object of string dot call. If you call this as a function, this will give you now is the validator here. Unless you say the object the prototype dot to string to call of this. Interesting. So this is now a property that we can have access to know and to understand to get you that, to get you the type of this. That's pretty interesting. To string call. To string tag, and the other is this, the to string. Return a string representing this object. This method is meant to be override by derived object for custom type coercion. Exactly. Whatever object that you're going to pass me here, okay, whether it's undefined, this is an automatic way to determine is the type of something. That's mind-blowing, bro. That is a mind-blowing stuff, this. So if you want to detect is the type of something, you're going to pass that. You say, hey, this will be now is the validator, right? And then you say data, where now here, so JavaScript has now this built-in function that allow you to, but it has to be through prototype, okay? That allow you to now call that and return you the type of this. Object.prototype to string.call and pass the data. So if you call now here the validator, with whatever name it is gonna give you those properly. Validator here, so new map, or validator here with undefined. Or validator, not a number. That's interesting. Hey, whatever data I'm gonna get here, I wanna check what is that. That's powerful. Okay, to string and value of. Hey, we want to detect is the type of this value here, the type of this data, right? Whether this is a primitive or a non-objects or a built-in objects, right? Because for some reason you pass now this validator of some new, say, user. Okay, and then you right below you define is a user here. So the class user that say, hey, the class user, what is gonna call the constructor, and it's going to now assign this new object. Say this dot name, right? Joe. Last name Doe. It's gonna give you now this is an object. Exactly. Exactly, but not for custom not for user defined objects. Because for user defined object you use now the instance of. You say, hey, is in user is an instance of user. It's gonna give you that. That's interesting. It's very, very, very interesting. Because with that validator, you can also say something like that. Instance of user, then return this. Exactly. So this is how you can create now a validator of building objects as well as the built-in interesting building object and built-in building objects and user-defined objects. It makes a lot of sense. Has own property, is prototype of, to check what is the prototype change, and so on and so forth. exactly. To check that inheritance and so on and so forth. Okay, that was interesting. That was very, very, very interesting here. It was very, very, very interesting here. Mm-hmm. Mm-hmm. What about positive and negative numbers, bro? Mm-hmm. Mm-hmm. Okay. All right. Okay. Symbol values. Ta, 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 ta. Primitive immutability. Primitive assignment. String behaviors. Whether it's a string character access, character iteration, or even in there, you can now have access to this internal meta programming hooks known as the meta programming hooks. The specific of the iterator protocol include the fact that the value E results still show down false are covered in detail in sync and async. Mm-hmm. And the other is stream behaviors. Character iteration. So for example, like this. This means that the character code units of a string can be iterated individually. Like this. Mm-hmm. Mm-hmm. If they expose an iterator is that the values such as strings and are iterables via this, exactly, values such as strings are iterable via this. If they expose an iterator producing method at this special symbol property location, see as well known. Like this. But they expose this. So you can have access to the values such as strings and arrays are like that. See the well-known symbols. Yeah, see the well-known symbols. Mm-hmm. The spec used to use the notation at symbol to denote well-known symbols. For example, symbols has instant, has written as has instant, and the array.prototype symbol iterator will be called array.prototype this. This notation is no longer used in the spec, but you may still see in older documentation of discussion. Well-known symbols do not have the concept of garbage collectability because they come in a fixed set of uniques throughout the lifetime of the program, similar to intrinsic objects such as array.prototype. So they are also allowed in weak map, weak set, weak rep, and finalization registry. But all static properties of a symbol constructors are symbols themselves, whose values are constants across realms. And we're gonna see what that F is realms. And a realm is something that is created, man, by the language. They are known as the well-known symbols, and their purpose is to serve as protocols for certain built-in JavaScript operations, allowing user to customize the language behavior. For example, if a constructor function has a method with symbol has instance, and exactly, they are known as well-known symbols, and their purpose is to serve as protocols or meta-programming hooks. Protocol for certain built-in JavaScript operations, allowing user to customize the language behaviors. For example, if a constructor function has a method with symbol.hasInstance, as it is named, this method will encode its behavior with the instance operator. But again, this is the purpose of symbols is to serve as protocol for certain built-in JavaScript operations. You can override that behavior. To serve as protocol for certain built-in JavaScript operations, for these abstract operations, allowing user to customize the language behaviors. Exactly. So you can customize the language, you can customize certain language behaviors via these well-known symbols for those objects that implement that. In other words, symbols is used as a way to override the behavior of certain metaprogramming hooks or protocols that are in certain built-in JavaScript operations. Okay, for example, such as iterable. So here it has now a reference to that. Hey, I want to reference is to this. I want to reference is to primitive in that object. A method converting an object to a primitive value, a string value used to default description of an object, used by object.prototype to string. Unscopable. Search, a method that returns the index within a string that matches the regular expression. Replace, match all and iterators and has instance, is concat spreadable and async iterators. And the other is the iterator, a method returning the default iterator of an object used by for of. Okay, again, all of this is metaprogramming here. Interesting. Very, 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 very interesting. Very, very interesting. Okay. Okay. And the other is the length computation. Okay, here we go. And the other is the length computation. All right. String behavior, string character access, character iterations. Okay. Where now these arrays, where strings behave like an array. Okay. That allow you to iterate using is the of. All right. Using is the of this string, like all of these character too. Well, in is used for key objects or records, iterations. this is character iterations, right? And also that you can override is the behavior of that. Okay. So you can now have access to that internal behavior using as a symbol iterator, these known symbols, which are private property. It's like private property that allow you to have access to specific hidden properties, or in our case, is that allow you to have access to specific protocols or meta programming hooks here. Interesting. And then we're now in the length computation. As mentioned in the chapter 1, string value have length property that automatically expose the length of a string. This property can only be accessed. Attempts to set are silently ignored. The report length value somewhat corresponds to the number of characters in a string, actually code units. Exactly. But as we saw in the chapter 1, it is more complex when Unicode characters are involved. Most people visually distinguish symbol as separate characters, and this notion of an independent visual symbol is referred to as grapheme or a grapheme cluster. Graphema. Grapheme. In Spanish, un grafema es un símbolo de un conjunto de, exactly, or a grapheme cluster. So when counting the length of a string, we typically mean that we are counting the number of graphemes. But that's not how the computer deals with character. In JavaScript, each character is a code unit 60-bit, which code points value or below 65535 with a code point value at or below to this. The length property of a string always counts the number of code unit in a string value. Exactly. No, not code points. Code units is a string value, not code points. A code unit might represent a single character by itself, or maybe part of the surrogate pair, or it may be combined with an adjacent combining symbol, or part of a grapheme cluster. As such, length doesn't match the typical notation of counting visual characters graphemes. To get closer to an expected intuitive grapheme length for a string, the string value first needs to be normalized with normalized NFC. See normalizing Unicode in chapter 1 to produce any composed code unit where possible. In any case, characters were originally stored decomposed as separate code units. For example, like this. Favorite items is teléfono is length 9. Favorite items say normalize this to be this. Unfortunately, as we saw in chapter 1, we still have the responsibility of character of code points greater than this, and thus needing a surrogate pairs to be represented. Such character will count double in the length here, which is an old phone. However, a mother phone or a cell phone is not give you now this. So what do? One fix is to use character iterations via operators, as we saw in the previous section, since it automatically returns each combined character from surrogate pairs. Exactly. But unfortunately, graphemes cluster As explained in chapter 1, throw yet another wrench into string length computation. For example, if we take the thumbs down emoji and add it the skin tone for medium dark skins, we get this. Exactly. And when we see the length, it says 4, but if we now spread that, we get now this composed into 2. As you can see, these are two distinct code points, not a surrogate pairs, that by virtue of their ordering and adjacency cause that the computer Unicode's rendering to draw the thumbs down symbol but with a darker skin tone that is default. The computer string length is thus 2. It will take replicating most of the platform complex Unicode rendering logic to be able to recognize such cluster of code point as single character for length counting's sake. There are libraries that purport to do so, but they are not necessarily perfect, and they come at a hefty cost in terms of extra code. As Twitter users, you might expect to be able to put 280 thumbs down emoji into a single tweet. Since it looks like a single character, Twitter counts default thumbs and medium black thumbs and even family emoji graphema cluster all as 2 characters each, even though their respective string length from JavaScript perspective are 2, 4, and 7. Thus, you can only fit half the number of emoji, 140 instead of 280, in a tweet. Twitter implemented this change in 2018 to specifically level the counting of all Unicode characters at 2 characters per symbol. That was a welcome change for Twitter users, especially those who wants to use emoji characters that are most representative or intended gender skin tone. Still, it is curious that Twitter chose to count all of the Unicode emoji symbol as 2 characters each, instead of a more intuitive 1 character grapheme each. Counting the length of a string to match our human intuitions is a remarkably challenging task. Perhaps more of an art than a science. We can get acceptable approximation in many cases, but there is a plenty of other cases that may confound our programs. So in other words, the length calculation here is that any string has this normalize function. Any string has this normalize function. Okay. Has this normalize function. Has this formalize function. Canonical decomposition followed by canonical composition. Canonical decomposition. Compatibility decomposition followed by canonical decomposition. Unicode assigns a unique numerical value called a code point to each character. For example, the code point for A is given as this Unicode format. However, sometimes more than one code point or sequence of code points can represent the same abstract characters. The character ni, for example, can be represented by either of these single code points or the composition of this. However, since the code points are different, strings comparison will not treat them as equal. And since the number of code points in each version is different, they even have different length. Exactly. The normalized method helps solve these problems by converting a string into a normalized form common for all sequence of code points that represent the same characters. there are two main normalization forms, canonical and compatibility. Canonical evidence normalization, composed and decomposed forms. So, in other words, if you open up now here, and then you say, hey, is in equal to dareña, it say that this is true, all right, but you gotta be careful. For example, with e, right? That's interesting. Mm-hmm. Mm-hmm. This is length computation. So mm-hmm. to match our intuition of visual representation known as graphene, okay, to match our intuition of visual representations known as graphene, all right, exactly, known as graphene. Absolutely. Yeah, to match our intuition of visual representation known as graphene for composite letters, for letters, we can use normalize function. Normalize function. But for characters, okay, but for characters, depending how they are being encoded, but for characters beyond 65535, but for characters beyond 6555 or from the astral plane, for those type of character from the astral plane, now the representation is different. The representation use surrogate pairs or two pairs of 16 bits. Mm-hmm. And not to mention that you have now graphene clusters. Graphene clusters. So graphene cluster throw yet another wrench into string length computation. For example, if we take now thumbs down emoji and then add a skin color, as you can see, there are two distinct code points, no surrogate pairs, that not exactly, there are two distinct code points, not surrogate pairs. By virtue of their ordering of adjacency, cause the computer Unicode renders to draw the thumbs down symbol but with a dark skin tone that is default. The computed string length is thus 2. It will take replicated most of the platform complex Unicode rendering logic to be able to recognize such cluster of code points as single characters for length counting sake. Yeah, it will take replicating most of the platform complex Unicode rendering logic to be able to recognize such cluster of code point as single character for length counting sake. There are libraries that purport to do so. So still it is curious that Twitter choose to count all Unicode emoji symbols as 2 characters each instead of the more intuitive 1 character grapheme each. Interesting. So emoji, Twitter chose to count, I don't know if this is still relevant today. I don't know if this is still relevant today. But is this? Counting the length of a string to match the or human intuition is a remarkably challenging task, perhaps more of an art than a science. We can get accepted approximation in many cases, but there's a plenty other cases that may confound our programs. And the other is the internationalization. Here we go. Here we go. Internationalization, which is a topic that is discussed heavily, and I don't have any idea, bro. To serve the growing need for JavaScript programs to operate as expected in international language cultural contexts, the ECMAScript commit also published the ECMAScript Internationalization API. A JavaScript program's default to a local language according to the environment running the program, the web browser page, no instance, etc. The in effect local affects sorting and value comparison formatting, and several other assumes behaviors. Okay, this internationalization to match this language culture context, it takes now the local language according to the environment running the program, the browser or the server or any other, and then in effect local affects sorting, the in effect locale affect sorting and value comparisons, formatting, and several other assumed behaviors. So the formatting, the other assumed behaviors, the sorting, and value comparison. Such altered behaviors are perhaps a bit more obvious with string, but they can also be seen with numbers and dates. But string characters also can have a language local information embedded in them. String characters also can have a language local information embedded in them, which takes precedence over the environment default. If the string character is an ambiguous share in terms of its language locale, such as A, the default environment setting is in use. Depending on the content of the string, it may be interpreted as being ordered from left to right or right to left. As such, many of the string methods we'll cover later use logical descriptors in their name, like star, end, begin, end, and last, rather than directional terms like left and right. Okay, so that's why we have now this methods of the string method we'll cover later using logical descriptor in their name, star or end, begin and end, and last, rather than directional terms like left and right. And it's because the content of the string and the context as well. For example, Hebrew and Arabic are both common RLT language, exactly. So right to left. Hebrew and Arabic are both common right to left. Notice that the first list character in the string literal is actually the rightmost character when the string is rendered. Even though Hebrew is an RTL language, you don't actually type the characters in the string literal in reverse. Order the way they should be rendered. You enter the character in logical order, where position 0 is the first character position, position 1 is the second character, etc. Even though Hebrew in an RTL language, you don't actually type the character in the string literal in reverse order way they should be rendered. You enter the characters in logical order, where position 0 is the first character in the position, and the second is the second, and 1 is the second character, and so on. The rendering layer is where RTL characters are reversed. The rendering layer is where RTL characters are reversed to be shown in the correct order. That also means that if you access Hebrew hello 0 or Hebrew cellular char add to get the character of the position 0, you will get is that, because it's the first character of the string, not the last one. Logical, that last character of the string. Index position access follows the logical position, not the render position. Here's a sample in another RT language, Arabic, where you have all of these characters encoded, or code points. What is the difference between the code points? Yeah, I want to know what is the difference. Is the code point. See, as you can see, there are two distinct code points, not a surrogate pair. Exactly, because each one of those points are a surrogate pair. So you have now two pairs. Not a surrogate. Okay, they're code points, not a surrogate pair, that by virtue of their ordering and adjacencies cause the computer Unicode renderings to draw the thumbnail symbols, but with the dark skin. The computed string length is thus 2. But its rendering is the code units. Each character is a code unit with a code point value. Okay, code unit with a code point value. Because there are two concepts here. You have now the code unit, which is the character in 60-bit, and then you have now the code point, okay, which is the value from 0 to the range of 2 power 16, which is 655353. Okay, so code point value is the number that go from 0 to that 65, and the other is a code units that is the 16 character or the character itself. Code unit here. Interesting. JavaScript program can force a specific language locale. There we go. So, JavaScript programs can force a specific language locale using internationalization. APIs such as intercollateral. Internationalization and localization. And here we're talking about is collateral, such as this. So I can force the specific locale here. Exactly, so we can be all in the same page. Okay, makes sense. I can force this to be all in the same page. Alright, so I'm forcing here to JavaScript be on the same. If this is for educational purpose and things like that, if you're gonna enforce that everybody are on the same language, say same alphabet, you use an international collator. Interesting. Okay. List of German words, and then you have this German string sorter. You're gonna compare. I use the compare hello to wealth -1 or negative number. Examples adapted from MDN. German string sorter compare C and C 1 or positive number. So if you say something like this, and then, for example, you want to now make everybody on the same page, in this case Deutsch, and say hello is the same as hello, but in lowercase, it gives you now it gives you now 1, which is case sensitive. That's interesting. It's case sensitive. The internationalization collateral. All right. I want to be all in the same. I want to be all in the same alphabet. Okay. And I want to compare that. Negative or number -1 or positive if they are the same. Case first sorter, you say, hey, case first upper. Okay, so case first sorter compare case first, and it throw you now a -1. Multiple word string can be segmented using internationalization segmenter. Multiple word string. For example, you have all of these encoders or Unicode points. All right. Unicode points, and the other is Unicode. Unicode points or code unit. Exactly, code unit. Okay, makes sense. Okay. Code units. Code unit, it is the symbol in it itself, the code unit, and the other is a code point. Is where is this? Is what is the value of this? Code point is a value, and code unit is a symbol. That is representing a 60 bits. Okay. So in other words, when you look at this, the code unit, these are two distinct code points. Not a surrogate pair. And here what it's doing is multiple word string can be segmented using internationalization segmenter. Granularity word. Select the segment word. Okay, for let the segment word is word like. Okay. Of Arabic segmenter dot segment Arabic hello world. So if word like, so segment is word and is word like. Oh, it's a property that they give you. Oh, it's a property that this is gonna give you as you iterate through this. Okay, interesting. That's interesting. That is gonna give it to you. Internationalization segmenter. Object enable local sensitive text segmentation enable you to get meaningful items. Enable you to get meaningful items, graphemes, words, or sentence. That's interesting. So hey, I want to get is this. I'm using as a symbol iterator to get each particular value here. So for example, if I do something like this, okay, enables objects. Objects enable local sensitive text segmentations, enable you to get meaningful items, graphemes, words, and sentence from a string. Holy F, bro. I don't know, is newly available. Baseline is 2024. So I don't think, unless you're using for some, I don't know, some sort of model bundler that allows you to do that. But in other words, it's like, yeah, it's like what? Internationalization segmenter. That makes a lot of sense. Collateral and the segmenter. But all of them are part of the internationalization. Internationalization collateral, datetime format, display names, duration format, list format, local number format, plural rules, relative time format, and segmenter. This is something that is fairly new, right? Fairly new. Fairly new. Polyfill of internationalization segmentor in format JS. Okay. You take a look at this, right? And you say French. And for some reason, if you want to add some sort of grapheme, let's say here, and then you want to get that value, and it's give you now meaning characters, bro. It's giving you now meaning characters, bro. It's giving you now meaning characters here. This is something that we need to know. The length here will be 4 because it's now a graphene constellation. It's a graphene constellation. In granularity by word. That's interesting. That's very, 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 very interesting. That's very, 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 very interesting. Let user insert only text. Hero section with title, sanitize input, right? Stop, man. Stop, fella. Use the internationalization. Exactly. Or use the internationalization here. Intersegmenter. Exactly. Use the internationalization segmenter. Title meaningful word counter. Input text sanitize input. Hero section with title meaningful word counter. Input text. A list. Exactly. A list to add all the buttons. A list to add all. A list to add all the meaningful word. Mm-hmm. A list to add all the meaningful words. Simple, simple, simple. Mm-hmm. How to segment text into words and manage them interactive. Exactly, it's using this. Reset, hover, word list H3, word item, keyframes lie in. So it's using the function add rules, another add rule for that. Maybe for word collection. The process text. Exactly. It's greater than that. The process text, sanitize input to replace any HTML brags and things like that. Initialize event listener, and there you get. So one small step for man. One. Okay, doesn't allow me. Okay. Okay, the sanitization is happening. That was quite straightforward, you know. It was quite straightforward. That was quite straightforward. In focus, bottom, disable, not disable hover. He's using now some complex here. Not, which is another pseudo class. Another pseudo class here, disable on hover. On before, on hover, word list, keyframe. He's creating is a class constructor. Handle input change, segment text. That's interesting that he's using a class. Update bottom state, add next word, sanitize input, remove HTML tags and dangerous for that. And then you have this, which is one small step for man. One giant for mankind. Mm-hmm. Including icons, because it's that. I'm gonna make it simple, bro. Because you are complicated the logic here. Unnecessary. You are complicating the logic unnecessary. And the other is a string comparison. String relational comparison. Lexicographically. Like you will store word in dictionary and thus they'll be fairly self-explanatory. To that locale tempo. The lexicographical ordering, bro. No, okay. Exactly. But it's this one. Filter for meaningful word. Letters, number, emojis. Letters, numbers, and emoji. Because you're gonna use this the segmenter with the granularity word. Enforcing is the locale of n, and then say, hey, I want to transform is that text, all right, that I receive here. That text that I receive here into now a collection. A collection where I want to iterate all of this thanks to the segmenter that is gonna give me now segments, and therefore now iterate through all of this and well count that because that's what it's doing by pretty word like that, right? You say, hey, segment is work, this is emoji. this emoji, this is emoji, simple emoji detection using Unicode range. Remove the okay. Okay, no, but this is another one. Okay. Alright. So that'll be all for this video, and we talk about now a very important aspect here, which is the strings behaviors, string characters, iterations, length computation, and internationalization, fellas. Internationalization and location. Exactly. Internationalization and location. Because depending on the content, okay, to serve the growing need of JavaScript programs to operate as expected in any international language cultural context, the ECMAScript committed also published the ECMAScript Internationalization API. Is this one. So let me take a look what it does. One small step for an emoji, one giant leap. It crashed, bitch. I don't know why it crashed, man. Because it's not using the internationalization, man. This segmenter, granularity word, but you have access to. But when I do this, and then I want to iterate through that, right? Which is, I was going to iterate through this string 1 of, or in, no, of the value here. And then I want to console log is each one of them. And you say segments, right? Where now I'm going to have access to the. I'm gonna make this in English, right? Segmentor English, where you're gonna pass is the segment. All right, this is now in English. granularity work, you're gonna pass is the text here. Alright, and therefore you're gonna do is this, right? And I want to iterate through all of these segments, my friend. Or you might word as words. That's all. I don't know why you are actually so tripping here. Exactly. I don't know why it is quite interesting. Exactly, it's refining and it's refining, and in this refinement is like you're losing a lot of time that you can dedicate to understand how the things work. All of that time that you dedicate to that, you preferably is to understand how the things work or to build something. I think that'll be another way to do this. And is word like true? It's interesting because emoji are not considered as interesting. It's word like granularity. Uh-huh. Granularity. Mm-hmm. User perceived characters. And that's what happened. One small step for man, one giant leap. Only words. That's interesting because I'm telling you explicitly it's graphemes. Oh, okay. Interesting this correction. Interesting of this correction here. Interesting of this correction here. Graphene. There you got it. That's what happened. of course, when you use Word, it excludes other graphemes. It excludes emojis, bro. What the French does happen here, bro? Okay. Mm-hmm. This is not an example. Prom example. Prom examples, bro. Mm-hmm. This is useful for highlight concepts. No toma. Graphene, bitch. Okay. And that will work. What the fuck did you say, bro? Okay, now I cannot detect them. Okay. Oh, no, no, no. Okay. Jesus. French, those guys. Yeah, yeah, yeah. Oh, please. Local identification and negotiation. Local matcher. Why are you doing that? Mm. Mm-hmm. Mm-hmm. That's interesting. It's not only going to get that, because if you iterate through that, and it's telling you that is word like false. Mm-hmm. I get it. Exactly. There's some subtle stuff in there. This is for only get is meaningful word. Meaningful word. But if somehow you find it's an emoji, that's not. And that's why you have to be careful with that. Mm. Again, this is still on an experimental feature, right? This is still an experimental feature. This is still an experimental feature. Absolutely. Bottom to reset the input list of all meaningful word. Bottom with text next word. One small step for Yagame. Exactly, but and what you're doing is just refining this process until you want to explain or create is the product here. It's a small product to illustrate now, hey, how we actually do this kind of stuff. You see, and in the end it doesn't count that. Okay, so we have to go through that fixed list and identify what is the fixed list of emojis are. And we're using is a segmenter as a way to get now meaningful words. However, it doesn't include emojis. It doesn't include emojis. So that'll be all for this video. Take care. Bye bye.